brain output is to turn things off. It's inhibitory, because otherwise the system would just kind of run rampant and get out of control. Because brain cells are designed to fire, so we need to kind of keep them in check and develop some balance. Therefore, most brain cells are inhibitory, the vast majority. So what is it that the brain inhibits? And when we talk about brain, we're talking about the cortex. That's the outer portion, the stuff that looks like a walnut. So the four things that it inhibits, and this sounds like mumbo jumbo, and we'll just run through it and we'll get back to it. There's four forms of inhibition. Number one is it inhibits anterior flexor muscles above T6, that's basically the middle of the body, and it turns off, inhibits posterior flexors below T6. Secondly, it inhibits the inhibition, and I'll explain that, of anterior horn cells. 3, it inhibits your IML, that is your stress response. 4th, it inhibits secondary stimuli. Okay, so that just kind of outlines them so you can have them in one place, and we'll cover each of them and why this is some of the coolest stuff that you have ever seen. So the first one, inhibition of anterior flexors and posterior flexors. This is what allows us to be upright, to be biped rather than quadruped. And this is one of the most recent developments in evolution, if you will, that humans have a different brain than four-legged animals. And that brain, the cortex, is more developed, and most of that activity of that cortex actually goes to regulate how we function as two-legged creatures. So here's how it works. If you look at, and this is one of my favorite records, by the way, this is Supertramp. And they have this illustration that I borrowed. So when something is bent forward and the arms are turned in and back, that's a flexor posture. If you think about how babies are born, they are, if you put a baby down, do they lie straight and flat, or do they kind of pull up like a rubber band? Their legs fall out and they pull up. Are their arms really nice and straight, or are their arms kind of pulled in, right? Because they haven't developed these reflexes to inhibit that. And what happens to older people as their brain activity decreases, then they start getting more crooked and going back into this posture again. Okay? So what is inhibition of anterior flexors? It basically means that it's the muscles of the shoulder and arm that, in order for them to hang straight and for you to be upright, those need to be turned off. What happens in a stroke, when someone has a physical brain lesion that just kills off a whole bunch of brain cells, so they lose that inhibition, then that shoulder will pull in, the arm will bend, and the hand will flex. This is called a decorticate, means you disconnected the cortex, decorticate posture. And you can look at any sort of report on brain trauma, and you'll see things like that. So we can look at someone's posture, and we can see which part of their brain is weaker. If someone is standing like this and their left hand turns in like that, we know that's the weaker side of their cortex, because it doesn't have the same strength to inhibit those movements. All right? If someone also has a stroke, what you see on the posterior portion is we lose the inhibition of posterior flexors, so their foot is going to turn out and they're going to come stand like this. Okay? So those are the little most subtle things that you can look for. But basically, that inhibition is what determines our ability to be upright and walk around. And this is also why posture is so important, because when you have a stress response, then you're disconnecting the cortex and you're having less inhibition. So what do wrestlers and boxers look like? Okay, they're in a defense mode, so they activate their flexors by turning off that inhibition. So anyone who's threatened is going to look like this. Anyone who's at peace will look like this. So that means when people get really tense, they do this. So that means when you try to relax, when you try to make your brain work better, you can help out by finding a better posture. It works both ways. All right? Next, inhibition of the IML. That's a fancy word, stands for intermediolateral cell column. And that is basically where all of the cell bodies that give rise to the sympathetic nervous system. So those are the actual physical things that give rise to a stress response. And the brain inhibits those cells. So what does that mean? It means that whenever you have a stress response, that's going to kick in automatically to save your life, because you don't have time to think about it. Whenever something surprises you, you go on full alert immediately. But with a high functioning cortex, that can quickly turn off that stress response and balance your body again. The weaker brain will not be able to turn that off so quickly, so that's why a lot of people stay in a stressed state for a longer period of time. That's when we run the math testing here. The people that have the best functioning brain, you do the math and you tell them to relax and they settle right back down. But the better the brain works, the faster you'll turn back off. And if it's not working so well, then that stress response just goes on and on and on. Okay? So there's a reason that we do that stuff. So basically, obviously, this is hugely important, the ability to turn off the stress response, because that's everything we've talked about in previous sessions. All the diseases, your healing response, your digestion, blood pressure, cortisol, all those things. The brain ultimately, the cortex, is what turns off that stress response. Okay? It's wired to turn it off, but first the brain has to be strong and functioning. And this is huge. The wording is funny. Inhibition of anterior horn cells. So what does the anterior horn cell do? That's in your spinal cord. There's a place called the anterior horn. And in that anterior horn, that's the cells that send out signals to your muscles that determine muscle tone. And because you don't want your muscles to be in a spasm, because you want some regulation, there's a default inhibition. There's a built-in turn-off in the spinal cord of those cells. So when we want to turn on those muscles, the basic muscle tone, then the cortex turns off those cells that turn off the motor response. So a minus and a minus becomes a plus. Essentially, the brain determines the muscle tone in your body. The cortex is what senses and regulates that basic muscle tone. So what does that mean? Basically, at the simplest level, the muscle tone determines your reaction time. So if someone is walking and stumbles, if you have a good high muscle tone, you will catch yourself very, very quickly. If you have a really low muscle tone and a really slow reaction time, your face is going to hit the floor before you know it. And this is why elderly have so many falls. That's why they're so unstable, because their brain reacts so slowly that they don't know that they're falling before they're halfway to the ground. Okay? And I've looked up some statistics from the Center of Disease Control. Falls are the #1 cause of injury death in people over 65. There's over 18,000 deaths a year. There's 2.2 million falls going to the emergency room every year. Out of those, 581,000 are hospitalized,